is for exercise 3I, question 6 from method 1-2. So we want to find, for m and n rational numbers, show that these have rational solutions. So rational solutions, we automatically go solutions, I want the discriminant, so b squared minus 4ac. My b is this value, my a is this value, and my c is that value. So my b squared would be 2m plus n squared minus 4 times a times c. Okay, and I want to expand it. Okay, so we want to ultimately get an expression for the discriminant, and we can show that it's going to be a perfect square. Remember, rational solutions means the discriminant must be perfect square. Okay, perfect square positive. Okay, so let's do this. So when I expand this, I get 4m squared. 2m times n is 2mn. Double that is 4mn. N squared minus 8mn. Okay, so let's simplify this. So we've got 4m squared minus 4mn, because these are like terms, plus n squared. Now, this is the discriminant. It's not very helpful because I can't tell much from that. But what I need to realize is that this is actually a perfect square. We can factorize this. We can factorize this as 2m minus n all squared. Why do I know that? Because if I square 2m, I get 4m squared. If I square n, negative n, I get n squared. And if I go 2m times negative n, and double that, I get negative 4mn. Okay, so since this is a perfect square, so this is a perfect square, we know that it's going to be either greater or equal to 0, because no matter what value m and n are, okay, it says m and n can be any irrational number, it doesn't matter if it's negative or positive. If the inside of bracket results in a negative, then it doesn't matter. It's going to be positive anyway because we're going to square it. If it results in a 0, it's going to be 0, so that's fine. So since discriminant is a perfect square or 0, perfect square or 0, the solutions will always be rational. Okay, so you sort of need to notice that your discriminant is a perfect square, and since it's a perfect square, it will either be a perfect square or 0, so therefore your solutions will be rational. Okay, so that's all you need to write to prove that solutions will always be rational. So hopefully that helps.